we're going to continue our lesson on list. Okay, so we're going to first learn about references, object references, then object mutability, and then we'll talk about list mutability, concatenation, repetition, and slicing. And then we'll do some practice as well. Okay. So you already know that Python uses references, okay, to the object values. Okay. So for example, if you write number equals 2, it means basically the name number is referring to the value 2 or the object 2. Okay. So that's why we use the right arrow. Okay. So basically in Python, basically pretty much in programming, this assignment expression it's a one-way equation. It works from left to right. Okay, so in mathematics it works either way, right? But don't get confused. In programming, it's usually left to right. Okay, and it says number is referring to this value. So we say number refers to memory location of value 2. Okay. So basically, reference of an object is the memory address of the respective value it's pointing to. Okay. So the variable name, for example, in this case, number, basically uniquely identify this reference. So memory locations have these unique values identified by unique integer values, and we call them address. Okay, memory address. So for a given object, this reference value is unique and constant during its lifetime. So regardless the size of the object, okay, the reference size is 8 byte for 64-bit Python build or 4 byte for 32-bit Python build. Okay, I didn't say particularly 64-bit machine and 32-bit machine because in a 64-bit machine, you may be running 32-bit Python build. Okay, so it's actually the build that matters. Okay, so usually, currently these days, the 32-bit machines are a thing in the past. So almost every laptop or computers we get these days are 64-bit. So there's 64-bit Python build too. Okay, so in particular to my machine, it's the reference size is 8 bytes. Basically, my machine runs 64-bit Python. Okay. All right. So you can get this value using ID function. Okay. So pass your object to ID function. It returns this address as a integer number. Okay. So you can think of this as the social security number. Okay. All right. So in C Python representation, it actually, the ID returns the address of the object. Okay. So that means basically you can use the ID to verify the identity of objects. And we have been using it already. Okay. So you can use the ID to verify identity of an object. Okay. So you can use is operator to compare identities. Okay, so it's returned true if both object refers to same value. Okay, so for example, numbers 1 equals 1 and numbers 2 equals 1. So number 1 is number 2 basically returns true. Okay, so let's check that out. Okay, I'm gonna go here, So slide 4. So I have this. I think this should be numbers 2. I'll make that correction. And let's run this. Okay. You can also verify this with ID function as well, because is operator actually inside use the ID function. Okay. So let's run this. Okay. So right, it's true. Okay. So both these names referring to single object in memory. Okay. All right, so let's move on. So there are changeable objects and we call them mutable object. Okay, so if it can change during its lifetime, we call them mutable object. So that means basically it may have the same ID value, but the value ID, but the value may change. Okay. So the opposite is basically the object is not changeable. So we call them immutable objects. So objects like strings, tuples, ranges, bytes, and frozen set. So we'll learn about frozen set in the set lesson. They are immutable in Python. Lists, sets, byte arrays, and dictionaries, they are mutable in Python. Excuse me. So there are benefits to either of these categories. Okay. So understand that immutability is a restriction. I mean, it prohibits changing, right? So it's a restriction. So that means that restriction is not allowing to be changed means it's safe. So someone allegedly cannot change it, right? So it's basically that helps to keep usernames and password, which are strings, in web servers. Okay, and because of that, we can safely create multiple references to immutable object because, well, no one can change it. So it's safe to make a reference, not a copy, whenever needed. Okay. So mutability is a less restriction. So you can take, for example, you can take a list and sort it in place. So that's a change. You can append a value in into a list. So that's a change. So that means it's versatile. So there are more functionality possible now, but it's a cost, right? So when you make copies and Python still uses references, so basically if you use references, then if you change the original, it's going to reflect on uh, the copies as well. Okay. So the best thing to use is basically use separate copies, so clones. Okay. So the other thing that we need to know is Python list like collections of references. Okay. So basically it's a collection of object, but basically Python stores references to those objects. Okay. So inside its memory structure, Python in a Python list, it stores references to those objects. Okay. So that means basically two lists may share same object. Okay. So okay. So for example, if we have something like this, list 1 and list 2, they both equal 10, 20, 40. Okay. So we have this 10, 20, and 40 somewhere in three locations in memory. So what Python does is that when we create these two lists, basically those values now pointing to each of these values. Each of these positions in the list now pointing to each of the number values. And same for the list 2 as well. So now we have two lists pointing to the same set of values. So if any change happened on any of these numbers, and it's going to reflect in both, right? So let's check on that. Okay, so I'm going to go over here. Let's verify. So we're going to use the is operator to verify this. Okay, so I have the list 1 this and list 2 this. Okay, so basically I'm going to print this. Okay, and this will return false. Okay, there are two separate lists. Okay, so all right, and then so let's check on that first. Okay, so slide number 7. So we go here. All right, it falls. Okay, so that there are two separate lists. Okay, so let's check on now each of these value whether they are same or not. Okay, so basically corresponding values, value 0 of list 1 and value 0 of list 2. Okay, so let's check the identities of those. Okay, and likewise I'm going to check everything, every value, every corresponding value. Okay, so here, right here, all right, and let's run it. Okay, so number 7, and that's true, right? See that? So list 1 value 0 is list 2 value 0 as well. So that means they're not copies, they're just one value which happen to be both referenced by both lists. Okay, so they are true. Okay, so this is sort of the proof. Okay, so Python stores references to values. Okay, and you can also, so this is maybe we can do as a homework. You can also use memory size to prove this. Okay, so for that we're going to use system module and get size of method. Get size of method returns the memory size in bytes. Okay, and I already imported the module over here. Okay, right here. Okay, all right, so let's go back. Excuse me. All right, so if you use item assignment and ID, then we can prove it. And okay, so basically we create a list and go access an index, and then we can change it, and we call it item assignment. Okay, but if we do a reassignment, and that's not a mutation. Okay, all right, for example, we have list 1. Okay, and like this, and then we can print the ID. Okay, and then I can change. So this is item assignment equals 5, and if I print it, and you can see the list is now changed. So it's a mutability test. And if you print the ID, it'll be the same. So that is to show, okay, it's not a separate copy. We change the same list. Okay, so that's sort of the proof. Okay, all right. So and if you use reassignment, so list 2 equals now this, and we print the ID, and then basically list 2, I get a different list and then reassign. So this is a reassignment. See, I'm not accessing the index in my left hand side. So the whole is going to be replaced by this. And what happened to this? This value, basically garbage collector comes and then reclaim the memory by deleting this value. Okay. So this is not a mutability test. And if we check the IDs not will not be same now. Okay, so let's sort of prove now. Okay, so it's slide 8. So we go slide 8. All right, so right here. Okay, so let me print the ID value of the list one first. So I have the list one, and I'm going to print it again. Okay, so let's check for that. So slide 8. Okay, and notice the IDs are same. Okay, so we change the same list. Okay, and if you want to print it, print the value, and you can see that this operation went through successfully. So this interrupt 2 will have 5. Okay, and let's just print that as well. So I like to prove the fact that I'm throwing. So let's print list 1. Okay, so after that, basically, okay, so let me print it over here. Oh, that's fine. Yeah. All right. So this is reassignment. Okay. So I'm going to print the ID of this. Okay. And the ID of this again. Okay. So don't get into a misconception that we are changing the value here. No, it's not a change. It seems like a change, but in the memory, this value is not going to get changed. Instead, basically, this object's now referring to this value. Okay. So in other words, this guy lost his reference. So it's now garbage taking up memory. So garbage collector will come and reclaim memory by deleting it. All right. So let's run this, and okay. So now you can see that it's, yeah. So the two IDs are now different. Okay. Right. See 32 at the end and 92 at the end. So they're now different. Okay. So let's go back. All right, so let's go into list concatenation. We already learned sequence concatenation. It's similar. So you can combine a second list to the first end to end. Excuse me. You should know that concatenation creates a new list. Okay. So you can use the plus operator to concatenate. So that's concatenation is conceptually an addition. So you can use the plus operator. Okay. So if you have two lists like this, and then you can create a new list by adding them together. Okay. So let's check on that. Okay. So we're going to add them together. Plus, well, this has to be the case. We're going to use the names. So, and 2. Okay. All right. So let's run slide number 9. All right. So we got the concatenated list. Okay. So let's check. So I said, okay, this is going to create a new list, right? So you can verify using the ID values. Okay, so the ID of this guy would not be either of these, would not be the ID of either of these. Okay, so does this give us an opportunity to create a clone of a list? Let's check this out. Okay, so let's say I want to create a clone of this, like copy of this, separate copy of this. So let me try to create. So this is just a test. Let's try this out. Print. Okay. So clone. Okay, right. And then basically we're gonna try. So I want to create a copy, separate copy of this. So what I am going to do is I'm going to get this one and an empty list. Okay, so concatenation, right? So this one plus this. See what comes out. Okay, all right. So we got this, right? So what we need to do is then we need to verify, right? This ID of this and this. So we basically say, okay, so can use is list one. Okay, if they are equal, then it's not a clone. Okay, all right. So it seems like it's false. Okay, so that means this value is a separate list, and we got the same copy, right? So it's one way of cloning is you can use concatenation to a empty list. Okay, so that's one way of cloning. All right, so let's go back. Excuse me. We can also repeat a sequence as well as a list. Okay, so basically we have a number and we multiply, so we get sort of multiple copies combined together. Okay, so repetition also create a new list. Okay, so we use star operator, multiplication operator over here to repeat. So for example, we have list one and we can create a new list of repeated list one, in this case 10 times. So let's check this out. Okay, so okay, and we don't run. Okay, so we got 1 2 1 2 1 2 repeated, right, 10 times. Okay, so can we use repetition to create a clone as well? Because repetition also creates a new list. So can we use that to create a clone? Let's try that out too. Okay, so what I'm going to do is I'm going to create a clone of this. Okay, so print. Okay, so okay, oops. So it is going to be, so this time, what if we multiply this list by 1, right? So let's try that. Okay, so list 1 times 1. Okay, let's print that out. Okay, so we got the same value, and you can verify that the IDs are different. Okay, all right, so let's move on. Slicing, we learn about slicing in a in our lesson of sequences. Okay, so syntax, we have a list and start, stop, and step. Okay, so defaults are, for the start it's 0, for the stop it's the end of the list, default step value is 1. So stop is exclusive, so that means basically slicing happens up to the item before the list. Okay, so basically Python will go to the next index, the index before the last one, according to the criteria in the step value. Okay. All right. So slicing also creates a new list. Okay. So let's check this out. I think we have to go to the next slide. Okay. All right. All right. So you can also use negative step values. Okay. So like this one. Okay. So we have a list and then -2, and with these two value, I get this. Okay. So it's -2. So then basically the step value is -2 means that my start has to be higher than the stop. Okay. All right. So it's basically coming from right to left, right? So the start is 14, okay, and I'm skipping it's -2, okay, and up to 1, which is this one, and this is exclusive, so I can go all the only up to this one, the one before, which is 8. So 8, we got 8, okay. All right, start and end also can be negative. So that means basically we are using negative indexing, okay. So for example, right here, so the start value is actually default, okay, but the stop is -2, okay. So, and here still the step value is positive, so we go from this way, okay. So from the beginning, so we start from 2 and all the way go up to -2, okay, which is -1, -2 is this, 11, and it's exclusive, we all the way go up to 8, okay. All right. Slicing is fogging, and we learned that, okay. So if the criteria is not doable, but if Python think it can go up to some value, and it can basically, it will return that value. If it's not possible, then Python will return empty list. Okay. So let's check that out. So number 12. Okay. So this is our list. Okay. And so this is the slice. So let's print that one. And you can try many things. So try to mess with these values and see how things get, and then try to make sense of it by the rules, using the rules. Okay. And the rules, specific rule set, we discussed in under the sequences. So that's why I didn't want to repeat that. Okay. So there are certain set of rules for slicing, and we discussed this under sequences lesson in week 3. Okay. All right. So let's print that out and then print this one out as well. Okay. All right. So slide number 12, we get, yeah, this one, 14.8 and 258. So those are the value we had in the slides. Okay. All right. So let's try with some forgiving examples. Okay. So what I'm going to do is I'm going to try to print, let's say, like impossible slides, like slices. Like let's say we start from 10 and go for 20. Okay. So start 10. There's not 10 index, right? So 0, 1, 2, 3, 4. So beyond 4, there's nothing in here. So I'm expecting an empty list here. Okay. So that's all Python can do, right? So it'll do that. So it's better than crashing a program. That's why. So basic notion is that it's empty. Okay. And if I put, let's say, print one more time, and let's say like 3 to 20 or something, and 20 is the stop value, and we don't have that many, so it will go all the way up to the end. Okay. So I'm expecting, okay, so 0, 1, 2, 3, so 11, 14. So that's my expectation. Okay. On this one, okay, so I got 11, 14. All right. So let's do some practice with list. Okay. All right. The first question is, given two list, sorry, given any list, I think did I skip? Yeah. So given two list of numbers of equal length, write a Python function named add2list to return a new list of terms of summed corresponding items. So for example, given the list this and this, so I think I said equal length, it should be unequal length, okay? And this list expected result is basically 5, 5, 5, and then this list. Basically, we sum up each corresponding values, okay? So it also says minimize your computations, okay? So let's do an understanding umpire process for this one to analyze this problem, okay? All right, so I'm gonna go full screen over here, so we don't need to see the slides anymore, okay? So let's read it again. Given two lists of numbers of unequal lengths, write a Python function named add2list to return a new list of terms of some corresponding items. For example, given the list 1, 2, 3, and this one, your function must return 5, 5, 5, 1, 2, 3, 4, 9. So basically, 1 plus 4 equals 5, 2 plus 3 equals 5, and 3 plus 2 equals 5, and then there's nothing after that, so just nothing to add, so we have that. So it basically, it's a common sort of case that they are not, the two lists are not equal, okay? So first the input, okay, they are list of numbers, okay? So it's really important to get that out as well. I'm not just giving just two lists, it's a list of numbers. Okay, so we don't need to worry about having non-numeric values in our list. Okay. So, and the output is basically the sum. Okay. I can simply write the sum of values. Okay. All right. So let's take this example. Okay. So I have this, and I have this. I can simply like write it like this, and then we can basically, all right, so I'm gonna do a add mark over here. So I'm going to put an add mark over here. So basically now this is equals, okay, all right, the return list 5, 5, 5, and then we are adding nothing to 1, so just 1, likewise 2, 3, and 9. Okay, so this is what I have to return. Okay, so as we can see, we have to repeat the summation. Okay, so this is a classic for loop problem. So what did we repeat? The task that we repeat is the summation of each corresponding values. Okay, so in this case 4 and 1, adds up to 5. Okay, so basically match, we can write like um, the previous list problems, because they all involve a loop. So sum of, right, sum, I think sum list or something like that, like sum of numbers. Okay, right, any iteration list that iterate numbers. Okay, all right, so we need to get the data. Okay, so list 1, and there are 2 lists, list 2. So I went into plan. Okay, so which is the algorithm. So second step. Okay, so now I need to figure out which one is the smallest, right? So my strategy here is that basically once I figure out the smallest list, okay, and basically then I can take the other list and then clone it, okay, and change only this up to this, the smaller list values, okay. So that's what it means by, okay, minimize your operations. Do I have to iterate entire list of the larger list? No, I don't have to. Okay. So basically, I need to initialize the, like, say, sum list, something like that, into an empty list. So that's basically init, initialize sum list. Okay. So, and then third step, we need to figure out which one is the largest. Okay. So, and then basically iterate the smaller one. Okay. So we have to use if else over here, right? So let's say, right? Let's say now we are picking a list, which one is the largest and which one is the smallest, right? So let's say if, okay, all right. So if L list one, length of that, okay, 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 is greater than or equals, we need to take care of that as well. Okay. And if this is the case, okay, list 2. All right. All right. And then, so we have to go inside if, so 3.1. Okay. And we need to create a new list and then make it equal to that, right? So I'm gonna add one more over here, right? Say shortest equals this, and short equals this too. Okay. Okay. And then else basically, all right, else, all right. So basically 3 point, so this is 4, step 4, and 4.1 basically short. Well, we are writing algorithm. Sometimes I mix the two. Short is list 1. Okay. So let's write it like that. Okay. All right. So now we figure out which one is the short. So we need to iterate that short one. Okay. So fifth step. and 4. Okay, so on the length of, right, so of the short list, right, so for items, not item, indexes. Okay, so for all indexes of short, okay, and so we're going to go inside for loop, so 5.1, and add up to take the corresponding index of the longer one, and basically all right, so we need to add up corresponding indexes, right? So that means we actually need long as well. Okay, all right, so is this one, and then long is list one. Okay, and otherwise long is sort of like this. Okay, so this is the algorithm. So right, so long is list 2. Okay, all right, so we are iterating the short one, and we're going to add corresponding list. So basically sum list okay, so first we need to over here we need to create step 5. We need to initialize this guy with the longest. Okay, so sum list, okay, equals the long. Okay, all right, so once we do that, now we can basically index, so basically update, okay, sum list values with the sum, right? Okay, all right, so that's it then at the end. So this is step 6.1. We return the value, so 7, return sum list. Okay, all right, so let's convert this to code now. Okay, so we take list 1 and list 2 as parameters. Okay, so list 1, list 2, okay, and then so we replace this, so sum list. Well, we are also initializing here, so we can do it there actually, so let's leave that and start our these two. Okay, so short equals this, and yep, and long equals that, and if, okay, so you can copy this one directly. Okay, and that is the case. Okay, so short is list. Okay, so short equals list one, oh sorry, list two, and long equals, oops, all right, list one. Okay, and else, okay, else it's the other way around. Okay, so this is going to be long and this is going to be short. All right. All right. So now we iterate. Okay. So for indexes in range, so it's index-wise iteration. That's the easiest. Okay. Okay. And then length of short. All right. And go in there, and before that we need to initialize sum list, right? So okay, so let's initialize that equals to long. Okay, all right. Now sum list, oops, equals sum list index, sorry, equals, right, short index plus long index. Okay. Okay. Notice we are not overpassing the length of long, right? So we are only going up to the length of short. So there's no risk of getting list index out of bound error over here. Okay. So at the end, we return sum list. Okay. So return sum list. Okay. All right. So let's see. Let's run this one. Okay. I think it's over here. All right. So I need to supply two lists over here. Okay. So list one. So the idea is basically you can mix these two parameter values. It should still work. So for example, if you put two here and one here, either way it should work. Okay. All right. So let's check this out. Okay. So we got the answer 555, 12349, which is the expected result. All right. So next question. So go back to our presentation. All right. So we did this question with for loops in our lesson one. So let's try to do this with both while loop and also comprehension. Okay. So I have already copied the problem and the respect to understand umpire process. So that is this. Okay. So we did this. So we understood and we did the plan and we implemented using for loop. So we're going to do it using while loop. So what I'm going to do is basically I am going to take the plan in for loop and convert simply to while loop first and then a concatenation. Okay. So this is one. So that's going to be first. So we get the data. We take parameters to function. Okay. So we initialize the sum. And then basically we need to cover all the items in in the list. So we have to use the length and parameter inside to create a Boolean expression in the while loop. Okay, so let's first initialize the sum. Okay, so sum equals 0. All right, oops. All right, and then while. Okay, so I need a counter here, right? So let's say count. Need to initialize that. Okay, while count less than the length, right? Length of the A list. All right, so this one. All right, while this is true, I need to get access each value in my list and add it to sum. So sum plus equals, okay, a list and count. But we have to, so let's go back to our plan. We need to verify whether these are numbers. Okay, so that means I need to modify this, right? So we need to use if, okay, right? So item is a number, right? So basically, then only I have to add the summation. So for that, okay, I am going to use is instant method. Okay, if is instance, okay, this guy, okay, all right. So it's, yeah, I have floating point numbers too. So is, oh, I need to pass int. So okay, and oh, should be O, right? And then the floating point part. Okay, so you need to check for both actually. Okay, so okay, and that is, if that is the case, I am adding some. So I need to do this. Okay, plus equals this one, and in here outside the while loop, sorry, outside if, I need to update the count. Okay, 1. Okay, and that's it. So we return the sum. All right, so let's check this out. So right over here, I need to add this one, and this is our, oh, okay, so that's an error. Let's see, what is it? Get some two. Oh, I think I did one. Okay, all right, there you go. Okay, so let's run. All right, okay, so I didn't get the result that I wanted, so I'm getting 0. I think I made a mistake. Okay, so okay, so let's check on this. Okay, so Ellie's count. All right, so here's the mistake I did. See, it's a silly mistake. So look at the operator. It should be less than. I put greater than. Right, silly mistake. Okay, that's why. So loop never went in. So Python didn't go in there because 0 is always less than the length. So I'm checking greater than, so it didn't go in. Okay, so that's why. So these things happen. Okay, so especially if the program ran, it's really hard to sometimes figure out the bug. Okay, all right, so let's run. And I'm expecting the correct value now, 6.5.